So hi everyone, welcome to this event. So what we are going to do today is we are going to talk about evaluations. And you will find a link to what we need today here in the course, especially if you're watching this in recording. So you just go under the video, and then there will be this link to the course. So go to site, and then you will see this link. So this is our free course about AI engineering for RAG and agents. And this workshop is a part of this course, but it's also a standalone workshop, right? So if you came here just to watch this workshop to learn more about variations, that's also a good place to be, right? So for some things, if you just came to watch this workshop as a standalone workshop, I already assume that you know things about RAG and agent. I'll do a quick recap for that. And if you're here watching the course, then you probably have watched the previous the previous modules, the previous lessons. So I see you're already asking some questions. I'll come back to these questions later. Right now, I want to focus on the logistics for the workshop today. So in this workshop today, what we are going to cover is the module number 4 of the course. So we are going to talk about evaluation of RAG and evaluation of agents. RAG contains, let me use my pen. So RAG, I'll just do a quick reminder for those who, just for everyone, right? So in RAG, we have a system where a user has a question. The question could be, maybe let me introduce our running example. So we have a lot of free courses, right? And people take these courses and they often have different questions. So we have this frequently asked questions database with all the questions, right? And the questions are like, hey, I just discovered the course, can I still join it? And things like that. If you just ask an LLM this question, I just discovered the course, can I still join it? The LLM will not know. So what we need to do is we need to take this data from here and inject this into our prompt that we send to an LLM, and the LLM will give us the answers. So this is the idea behind RAG. So first participant is asking a question, the question for our assistant. So this could be a bot in Slack. And then the assistant could, the question could be, I just discovered the course, can I still join it? So what the assistant will do is it will go to our search engine, our knowledge database. I'll call it knowledge database. And it will use this query to get data from this knowledge database, right? So what it sends is a query, and it gets back some document, let's say 5 top documents that match this query, right? So the documents that are potentially relevant to this query. Then what the assistant is doing, it's building a prompt. So it injects both the question and the data from the knowledge base. So we have here both queue and documents. And then this is sent to an LLM. And then the LLM is generating the answer and sending back the answer to our assistant, which in turn we show to the user. Right? So this is RAG in the simplest form. And what we will do today is we will evaluate the whole RAG, so this whole thing, how good this is, right? Is it generating good answers, or the answer is bad? The answers are bad, or if most of the answers are good, but there are still bad answers, what are those answers? But for most of the workshop, we'll focus on this part. So this part is search. And we will find out how good our search is, right? So because this is the foundation of RAG, so we want to test our search independently first, and then we will test the whole thing. Also, we talked about agents, and this is, by the way, everything I described. If you want a refresher, you can go to module number 1, and we cover both RAG and agents in many details. So if you feel like, if you're watching this as a standalone workshop and feel like you want to have a revision, so then I suggest you go check these things. Right. So I'm assuming here you know already some of these things to take most of out of this workshop. Right. So in case of agent, what we have, if we have a user and the user is talking to an assistant, right? But then the assistant is an agent that has different tools. One of these tools is search. And here I'm talking about Agentic RAG. So then assistant may decide, okay, like the user has a question and they have all these different tools, in our case, just one. So it invokes this search tool. The search tool goes to the knowledge database and gives back the results, and then it sends back the results to the assistant. But the thing is, the agent, the assistant, may decide to invoke search again, multiple times. So then it's up to the agent. So it's up to the agent to decide how to invoke the search function, how many times, with which arguments. So if previously we were always hard coding this queue as the query to our knowledge base, so here it can send some sort of variation like Q prime or whatever, right? So some derived, so it will not necessarily use the same question here, right? So here again we have this part, search, right? So we want to know how good our search is for Agentic RAG. As for usual RAG, search is very important. That's why the first half we'll spend really understanding how we can evaluate search. And then, yeah, this assistant is also returning an answer. Try to understand, okay, for this question, is this answer good? Like here, like for this question, is this answer good? But this is something have a very quick RAG revision. There is this module and this unit. But anyways, we now go to evaluation, right? Now I will also prepare the environment. Those who are taking the course already have the environment, but if you just discover this workshop and you want to follow along, I will show you quickly how you can set up the environment. The more there is a more detailed information about setting up the environment that you will find here, environment setup. I will very quickly do this because like my plan was to prepare this before the workshop, but I didn't have a chance because I was, of course, doing some last minute changes to the content. I hope my last minute changes didn't significantly impact the reproducibility of this workshop. But, you know, live demos are live demos. So now I'm creating a code space. So this is the environment I plan to use for the course, for this particular workshop too. And then inside this, I'm going to, like, once it sets this up, I'm going to open it in Visual Studio Code desktop. I prefer this more native feeling when I run it from the desktop app rather than from the browser, but you can run it from the browser too. It's up to you. But for some reasons, it is not opening, so maybe I should be a bit more insistent. So, okay, it opened. So, just a second, okay, now it's, my video is darker, but at least I can see what is on my screen. So I don't think you really care how dark my video is. You still see my face, right? Anyways, well, but at least now I can see what is happening on my screen. So I will close this thing. And now I have access to terminal. I pressed Control back slash. So sorry, back tick. Yeah. So then the first thing I do is I'm making this thing go away, right? So then my prompt is smaller. Then I do larger pip install UV. And then I will install all the libraries we need from here. Agentic RAG, environment setup. So these are the libraries we are going to need. So we will need also to install, okay, we'll need to install a few more, but we will do this as we go through the course. Right. Today we're not going to use vector search. We are just going to rely on text search. But those who are doing this, evaluating vector search will be a part of the homework. Right? So right now we keep things simple. So that's why we don't install any vector search related stuff. Okay. So yeah, we installed a bunch of things. Now I'm going to create a .env file. So this is going to be my, this is where I will put my I'll go to platform.openai.com and I will create a new key. So usually I prefer to create new key for every single workshop. So I will create a key. I'll call it workshop evals live. And now I'm going to stop sharing my screen because I'm going to create a secret key and I don't want you to see the key. And I will put it inside this .env file I just created. So now I can share it again. And another thing, so yeah, I'm going to create git ignore and then put .env .venv cache. Okay, high client CPU. I have no idea. Okay, so search. So what we will do, the first step is we will need to generate some data. So I'll call it data gen Python notebook. So the goal here is the task is to create a notebook that we are going to use now for the first part. So I'm just going to print 1, 2, 3 to make sure things work. Now I need to install the extension for Jupyter. So it's going to take some time. So you see it's rotating. And I see there is a question. I need to know which vector database you use. I don't want to necessarily endorse any vendor. So I think they are all equally good. So it doesn't really matter at the end which database you want to use. In our particular case, in case of the course, we use pgvector, but also there is a library that I implemented myself. There are actually 2 libraries that I implemented myself. So first, let me check, make sure these things actually work, and then I'll show you these libraries. But again, I don't think it really matters at the end. They are more or less the same. So just pick the one you like. And the reason I chose pgvector, I think it's like a very neutral choice. And yeah, as I said, you can use whatever you want. It doesn't really matter. Okay, so my environment works. I can see 1, 2, 3. It means that it works. So libraries I use. So first one is MinSearch. Is a library that we're going to use today Today, we're going to use it only for text search, but it also supports vector search, right? You can check for vector search, you can check this, this vector search module if you want to know in more details what kind of libraries we use for that and how. Okay, so the environment is ready, and I am going to go here and open lesson number 2 or unit number 2, right? So what we want to do now is we want to build our evaluation system that we are going to use to evaluate not only our search, right? So right now, the immediate goal is to evaluate our search right here. But also, we want to evaluate like the entire thing, right? So we want to evaluate if this answer is good, and also for our agent, if this answer is good. So that's the plan, right? So how do we do this? The usual way of doing this is we need to get as many questions like that as possible, right? So we interact with the system, we see which things work, which things don't, and then we collect this data. So this is first way, right? The first way is interact with the system, collect logs, and based on logs, you collect data set, right? So this will be, we'll call it ground, oh, not ground truth, it's not ground truth yet, but this is interaction logs, right? So these are the queries, queues. Let me do it like that. So use this notation, queue in square brackets, meaning like all the questions we want to use for evaluation, right? So that's one way of doing this. So manually, we interact with the system, we ask our friends, or we deploy our system and start collecting these logs. But then we also need to know, so here, this is the A that the system generated, right? So this is the system that our RAG generated. How do we know whether this answer is good, right? What we can do is we can actually have people who will see, okay, so our user, for this query that the user used, this was the search results. So we can, as humans, look at these results that the search system returned, and we can say, okay, for this query, document 1 is relevant and document 5 is relevant, right? So we do this ourselves by manually assessing this. So this is important, but this is not something we are going to do today, right? And also, like at the end, the human can look at this answer and say if this is good or not. What we're going to do today is we are going to generate data. So generate. So what we will do is we will take our FAQ database. So this is how our FAQ database looks like. Yeah, so I just discovered the course. Can I still join it? So here we have multiple things. So we have the question and we have the answer. So here we have the question and we have the answer. So what we can do today, so what we can do here is we see that there is an answer, right? So there is some answer. So first of all, let's start with our FAQ database. We have these pairs, Q and A, right? So these are the pairs we have. So this is our real data, our FAQ. And yeah, so this is our real data. So what we can do now is we can take the answer. So this is the real answer from our database. So this one, yes, but if you want to receive a certificate, you need to submit your project while we're still accepting submissions. So we can take this answer and we can think, so let's say I'm a user and I'm getting back this answer as the correct answer. Which question can I ask, right? So we are trying to go back from answer to the question, and looking at the question or looking at the answer, we can think, okay, if I landed on this page, what was the answer I asked, right? And then based on that, we can generate the question, right? So let me write a diagram. So we have an answer. So this is the answer from our database. And from that, what we can do is we generate a question. And I'll call it Q star, right? So this is a generated question. We assume that the user might have asked this question before they landed on this page with this answer, right? And we can actually generate multiple. So we can generate, let me remove this thing. We can generate as many as we want. So we can say that from this A1, we can generate, let's say, 5 questions, and all will be generated. So these are the questions that users can potentially ask before landing on this page, right? And we will use an LLM for that. So when we do this, we know that the answer for this generated question is this, right? So then we will have a set of pairs Q 1 star, the generated question, and A, and then 5 of them. So here we will know that for these 5 questions that we generated, A is the answer. So what we can do is now we can actually send this question. So let's say we are simulating our RAG, right? So what we can do is we can take this question, send it through our entire RAG system, and then get the answer. So I'll call this answer star, the generated answer, and then we can compare it with the original answer. And if they match, the answer is correct. If they don't match, the answer is not correct. For search specifically, we know like here we have these records, right? We have this D1 to D5 that are returned, right? And some of them are this answer. So out of them, like we want to check if answer is here, right? If it's here, then our search works. If the answer we were looking for is not there, it means that our search doesn't work. And then we can do this for all the questions we have. And then at the end, we can, this is what we can use to evaluate our data set. Okay, so this may sound a little abstract. So that's why what we are going to do now is I'm going to just generate the questions. And so probably all these things I was talking about, and I will be coming back to these diagrams. It will make more sense later. Okay, so I already did some preparation work. Well, we did together. In module number 1, we created a few helper files. So there were 2, and we are going to download them. So the first one was this one, load FAQ data. So this is the file that is actually, this is the helper that is downloading data from here, right? And then build index, this is a helper that is getting all this data and putting them inside the search engine. So I'm going to use this right now. So I'm going to download this data, download this, sorry. I think what I see is, I don't see the code I was supposed to push. Let me quickly check that, why it's not there. So maybe I forgot something, but okay, never mind. So if something doesn't work the way I want, I'll just improvise and we'll make it work. But what I will do now is I will take this thing and I will execute this, because what it will do, it will then load this file and put it here, right? So this is what we are going to use to get our data. So let me remove this one. So now we downloaded the data. The data looks like that. So we have question, we have answer. So this is our data in JSON format, right? In this workshop, I want to focus only on LLM Zoom Camp. So I don't want to focus on other courses. So I want to filter them. So we have only 79 questions. So these are the questions we are going to use for our assistant, for evaluating our assistant. Yeah, so this is not a large data set, and this is the reason I decided to choose this course and not other courses, because it will not take too much time to do this live, right? So we are going to use this data set as our main input, right? That's why for simplicity, I'll just call it documents. And I think I showed you already. This is how documents look like. We also have answer. Question. So we have document ID, we have question, and we have the answer. So we have the question, right? And this is the question that we have in our database, but then we can use this information now to actually generate a question that user can potentially ask about this thing, right? And then since we have the ID, we know from which ID this question is coming. And then later when we do search, we can see for this question that we generated, were we able to retrieve this ID, right? So this is quite important for us. And if in your data set, if when you do a project for the course or when you work on something similar and you want to evaluate your search, you need to assign an ID to each record in your database, right? Because otherwise you will not be able to know if you retrieve the right thing, right? If you cannot uniquely identify the right thing, right? And this is for us, the ID is important. And now we are going to use this to generate a question, to generate questions, multiple questions. For that, I'm going to use structured output. Structured output is something that it forces LLM to output, to produce an output in a structured form, right? So in this particular case, it will create a class with that follow this schema that follows this. So basically, we will just get as a response from an LLM, we will get an object that looks like that. Right? So this is really convenient when you need to generate structured data. You want to get an object that you can easily parse, and this is what structured output is for. We have not used structured, did we? I don't remember if we used structured output in our modules before. Maybe we did, maybe we didn't. But this is a really convenient thing when you want to extract some structured information, from text, right? In this case, we want to generate structured information. So this is the structure we are going to enforce on the response from the LLM. And I'll close this. And next, we will need instructions. So what exactly we are going to do. So the instructions are for the LLM, you emulate that the student might ask based on this FAQ record. The record should contain the type, the answer to the question, and the question should be complete and not too short. If possible, use as fewer words as possible from the record. So here, the last thing is we want to formulate it in a way that does not necessarily contain the words from the record, right? So maybe instead of, can I join the course, the person can say, can I enroll the program, right? So then it will contain fewer words, and this is actually good for our testing. Right. So these are the instructions. And now I want to make sure we execute that. Now I'll initialize OpenAI. So I use this slot.env from .env module to make sure I can read from this .env file, right? So this is how I configure the key. And then OpenAI client is what we are going to use. And since right now I don't see any errors, it means that I configured the client correctly. We have already done this. And now I'm going to take our document. So this is our document, right? So we have all these things. And I'm going to turn this into something that I'm going to send to the LLM, right? So I will say, hey, this is the instructions. This is the thing. Check this thing, and based on that, generate an answer. Of course, I can give it some structure, so I don't have to send this as JSON, but just sending JSON is also fine. Right? So then this is what we are going to send to the LLM. The first thing we're going to send is the instruction, like you emulate a student and you need to formulate 5 questions based on this record. And then we send the actual record. Right? So again, here I send JSON. You can make it like proper text without all this, stuff. LLMs are usually okay when it comes to understanding what is inside JSON. So that's why I kind of feel lazy and just send it as JSON. And then the important part is we use this OpenAI client responses.parse. So we still use the responses API, and this is what we were using. Now, if I go here, when we were just configuring, sorry, lessons, environment, RAG. So when we were just using the LLM, so what we were sending inside LLM, where is we have? Yeah, so we were using client responses create, right? And we didn't, we only specified, okay, this is the model we want, and this is the input we have, right? And we used a response output text. So what we do now is we use responses.parse, and in addition to model and input, we provide text format, right? So this is how we say, this is how we tell the API that we want to enforce a certain structure on the output, right? And the structure is described here in this question object or class, right? And now, instead of doing response output text, we do output parsed. And now this is our response. And this response contains these questions. So these are actually questions that we generated. Can I still join the course if I just found it? And what do I need to be eligible for a certificate? I don't really like this question, to be honest. Like, it's not what students usually ask. We can tune the prompt, right, to make this look more real. Is it okay to start the course late, or does this affect whether I can get a certificate? Well, let's be real. Students usually don't ask questions like that, but we can start with that. Like, the reason I don't want to go and change this prompt right now, even though maybe I'll just quickly show you that this is in principle possible. So what I want to say is the output should resemble how people ask questions on the internet, right? Not too formal. Yeah, like that. So this is, we'll remove. But I'm just showing that this is how you control how output looks like. I will just generate one more time. But then I will roll this back. No, I just found the course. Is it too late to join now? Can I enroll if I discover the course after I started? If I join late, will I still be able to get a certificate? What do I need to do to qualify for the certificate? We will keep that. The reason I'm a bit hesitant to change it now, because I already generated some of that I plan to reuse it, so we don't have to wait for these things to finish. But I think we can roll with this for now. Okay, let's go back. So now we did this for one question, right? So we did this for document number 1 that we have, right? For this document, I just discovered this course. Can I still join? Yes, but if you want to receive a certificate, you need to submit your project while we are still accepting submissions. Right? So this was the document from our FAQ database, and these are the questions that we generated. So this is, if we go back to our to my explanation. So these are these Q star questions, right? So the answer that we have is well, where it is. Right, so this is the answer, and these are the questions that we generated from this answer. I don't think people will actually use M dash. I don't even have it on my keyboard. Anyways, so but yeah, so these are the questions we generated. And now what we can do, as I said, or this is what we will do now, we'll just send it through the search thing and see if we were able to retrieve it. But in order to do that, we need to generate it for the entire data set we have, right? We have how many documents, like 70 something. Yeah, almost 80. So we need to do this for all the items we have, right? So let us do that now. For that, I prepared some utility classes, so things that I want to use in multiple lessons, in multiple units of this module, and I don't want to copy paste them from one notebook to another notebook. So that's why I downloaded. I put them together inside this utility script. There are multiple things. I will not go through them right now. I will cover them as we go along. But what I will cover right now is this LLM structured. Right, so this is the thing that we just did. Right, so we use this LLM to structure. We use this LLM call to structure this data. And before, if I still have it here, we just have this LLM, right? So now I want to turn this LLM function into something that output structure, and this is how it looks like. So it looks like LLM structured. We have the client, this is OpenAI client, the instructions, the prompt from the user, output type, and model. So I kept it generic, and right now I want to use this. I want to use this I want to replace this. So then our code becomes more modular, right? But what is happening here is I just put everything in one utility script, and I'm going to just import things from there. And one other thing, I don't know if I mentioned, yeah, I didn't put this here. For some reasons, the code didn't get committed. But what I also need to do is I need to have another file. I will explain what this file is later when we need it. So this is our RAG code. It's something that we implemented in module number 1. I'll go in a little more details about this file later. The reason I want to get it now is because our evaluation util depends on it. So you see it imports it because this is something we are going to import later. Okay, so if you're following along, it's just the same wget as we had here. Oops. Where for the ingest, right? I just replace ingest with RAG_helper. And later I will update this instruction. So if you're watching this course later, you'll see the updated instruction. Okay, so now I'm going to just use this thing. Oops, didn't import, didn't copy. So as I said, this LLM structured is nothing else but this code put together in a function, right? And now I want to use it here to extract questions from the document, right? So these are the questions. I just found the course. Is still possible to join, right? So this is not necessarily the same question, but this is the same process we used before. And then another thing we get from this thing, from this function, let me open it again. It's also we get usage. So usage contains how many input tokens we spent and how many output tokens it generated. So how many input tokens we sent and how many output tokens it generated. And this is how we can see how much money we spent on this request. So then I have a helper function for calculating cost. So the cost is for this particular model, GPT 5.4 mini, right? So if you use a different model, then you'll need to adjust, or if in the future the price for this model will change, we will need to adjust. Right now, these are the prices. So I just hard-coded them in this function for calculating price. So I can now use it here. Calculate price. Right. And what I can do is I can just get this usage thing, calculate price, put the usage there, and see what the price was. So it was what? Yeah, very low. So this would be 1 cent, right? So this would be 1/10 of a cent. This is 1/1000th of a cent, right? So this is pretty cheap. Okay, so this is how much we spent, and now I want to do this for the entire data set, right? So, yeah, that's another thing. Before I do this for the entire data set, I want to turn it into the right format. So just for this particular question, I want to turn it into this shape, into this format, right? So then we have question, course. We actually don't need course because it's for the same course. But what we need is and the document, right? So this is the document from which this was generated, right? We know that this question was generated from this document. This question was also generated from this document, and so on, right? So then later, we can actually see if we are able, when we evaluate search, we evaluate our search here, we can see if the answer we retrieve is among this. So we will just use this document ID. Right. So this is how it looks like. Now we need to do this for all the data sets, for all the questions. So let's do this for all the questions right now. Yeah. So for that, I think we already have the things we need to install. Oops. So I definitely have TQDM. I don't remember if we installed pandas. Yeah, because we want what we want to do is we want to turn these records into pandas, right, into pandas data frame. So it will be something like pd import pandas as pd, and then pd data frame. What do we call it? Records, yeah. So we want to turn this into this structure, into a data frame, right? Something we can easily save then later to a CSV file. So that's why we need pandas. So now we need to do this for all the documents. And here is where I want to import another function from this utility. So previously we used this LLM structured, and now I import this structured retry. So this structured retry is the same as LLM structured. So this is what we implemented together, but there is one extra thing. You see one extra argument that we have is max retries. This is what's happening is we attempt to use this LLM structured, and typically it should have no problems. But what if something happens, like this network issue, that sort, right? So instead of just and saying, hey, like, yeah, we were calculating this for these 79 documents, failed it, so sorry, your entire batch is ruined. Right? So instead of having to re-execute it just because one single failed, what we can do is we can just we are right now. We'll say, okay, we tried 3 times, still doesn't work. So probably the issue is how do you call it? Not transient, but like persistent, right? So it's recurring. So something is probably wrong here. So it's okay to file the entire batch. Okay, so I'm cutting off. I hope it's not too. Is it good now? So should I wait? So, okay, I hope my connection recovers. So what I was saying is maybe I'll repeat it one more time because connection was bad. Actually, Zoom doesn't tell me anything about my connection. So typically it just says, hey, your connection is slow. Okay, so what I was saying is we have this LLM structured retry. And the idea here is that, so yeah, I see that we didn't hear the explanation. Let me repeat it. So the same LLM structure as before, but when something happens, if let's say there is a temporary issue between us and the OpenAI server, we don't fail entire batch. So if we're processing our records and then at record number 78 out of 79 records, we hit an error that is just temporary error. For some time and repeat it. And if we still see time and total 1 times, so if at the end we still hit the issue, we think, okay, this is probably something is actually going on there. So let's actually raise the error. Otherwise, we just retry it. Probably if there is some sort of connection problem on the first attempt, typically it would resolve itself on attempt number 2. So that's LLM structured retry. So basically it's around LLM structured that is retrying multiple times. So that's what we want to use. And did so far, right? Everything we did so far, I'm going to put here. So what we did so far is we create a user prompt from a document. Then we use this LLM structure. It has the same signature as just LLM. And then we iterate over the questions that we get in the output. And then, as I said, we don't really need the course here. And we create data that looks like that. Right? So here we have question and document. And this is what we return. Right? And now we can do this for all the documents we have in our, for all the records we have in our database. I'll quickly check it. You can still hear me, because I am afraid that because this is hanging, so probably something is up with my connection. Okay, so we get the questions and then we get the response usage. Okay, so now what we will do is we will do this for take all our questions, all our documents, these documents, and we will apply it to every single document and generate questions. And for every single document, we will generate 5 questions. And I already have the code for that, of course. So this is nothing fancy. We just loop over the documents, and then ground truth will contain all these records, right? And then usages will contain these records, right? So we put everything together. At the end, I want to calculate how much money we spent. That's why I want to keep track of usages. And ground truth, this is something that we are going to use later to actually do the evaluation. So let's execute that. Okay. So something doesn't work. I hope for the next time I run it, it will work. So it shows, it was supposed to show progress bar, but it did not for some reasons. Maybe I need to restart. I don't know. Maybe at least I reopen it. So let me try. Ah, okay. So I see something. Let me try to do it for 5. Never. Did it? Oh no. So I think I need to re-execute this whole thing. This is annoying, and I don't know why it happened, but I will just quickly do this. I don't know if I forgot to do anything. And now let me... Okay, so now actually it looks like the way it was supposed to look. So I'm doing it just for 5 documents. We'll do it for more. So for 5 documents, it took 7 seconds. We can actually wait and do this for all 79. But I want to show you something different. So I want to show you a way to parallelize it. So we are not executing it on our machine. So what we can do is take our documents. So this is our documents. And then cut them into, let's say, 6 parts. Here it's 5. And then we can execute this in parallel, right? So then for this part, and for this in parallel. And then instead of waiting, I don't know, for 50 seconds, we'll wait only 10 seconds or something like that, right? So I want to execute this in parallel. And this is possible for us because we are just sending the request to OpenAI and we're waiting for the response back. You have to be a bit careful here when you send requests to OpenAI to not send too many at the same time, because then you will hit rate limit. 5, 6 time is okay. And then in this evaluation util that we have, there is a helper function. I'm carrying this helper function with me like for many years. It's very convenient. I don't want to go into details of how it works. It's a bit outside of the scope for this course. But if you want to understand how it works, what you can do is you can just copy and you can go to ChatGPT and then you is doing, right? And then it will actually give you an explanation. And then you can also ask follow-up questions, right? So if you want to really understand what's happening, yeah, do that. And I'm pretty sure the explanation is good. Yes, you probably can explain it better than I can. Right, so this is the function I want to use. And I'm going to close it. And now, yeah, I'll import these things. So thread pool executor is something that allows us to actually break this thing into, or no, actually it allows us to have like different workers. So this is going to be thread number 1, thread number 2, 3, 4, and 5. So each of these threads will be an executor that is pulling work from this common task pool, let's say, right? And then what we do is we just iterate over these things. We submit these things to this thread pool executor. Thread pool executor is evaluating them, and we are getting back the responses, right? So using it is very simple. We create this thread pool. We say that we want to have at least at most 5 or 6 workers. So the degree of parallelization is 6. And then we use this function. And so now I don't know if I should do this for everything. So maybe, yeah, let me do this. Let's see how long it takes. Shouldn't be too long. I hope I'm audible and we don't have connection, breaking connection. So please let me know if there were any problems after that connection break. Okay, actually it was fast. Again, 79 documents only, so it's fine. So now what we want to do is, I think we already had this script now. So we just go over results. So what results contain is, so this is result number 1. So this is for the first function, right? So for the second, and so on, right? So for them, we have this result. So we want to unsplit them. We want to put this in one list, and we want to put this in another list, right? So this is what we are doing here. We use extend. So extend, because records is a list, right? So what extend would do is it would just add all these things to the list, and append would just add one element, right? So now what we have as a result is this ground truth object, or sorry, list, where we have these pairs, right? So we have question, and we have the document from which we generated this question, right? And this is what we are going to use for evaluation. And then we also have usages, and what we can do with usages is we are going to calculate the price. So this is a very simple loop, right? So we just do calculate price for each of these usages, right? And then we can compute total cost. And this is how it looks like. So I spent 5 cents on that. Actually, I thought it would be cheaper. I think in my experiments, it was even less than 1 cent. But yeah, I guess that's the price. I wonder why it's now more. Maybe I did something wrong before. Maybe I did something wrong now. 5 cents, almost 6 is not a big deal still, right? So let me quickly check the price if I'm calculating this correctly. And I'll do GPT 5.4 mini. We have this model card. The price is correct. So, okay. So then this is the price. Okay, so this is the price. And what I will do is I have another helper function that is just putting this inside, so putting this loop. So because we will do this multiple times in this lesson today, so for me not to repeat myself, I just put everything into this calc total price. So then, yeah, I can just get this function and use this for calculating how much money we spent on the requests, right? So this is what I will use from now on instead of writing this loop directly. Okay. Well, and now we have this data. So we calculated the price. Now I want to save it. For you, you can actually save the data I already generated, or you can create this data set. So if you're watching this in the future, if sorry, I will update it with this. I'm just looking at this. I think it actually matches what I had. So I probably confused it with something else. Anyways, you, instead of generating it yourself, you can either generate right now the data I already generated, and in the future it will be this data that we generated right now. So I'm going to use that data. So now let me, I already imported pandas, right? So I already showed you what I want to do. So I want to just turn this entire ground truth list into a pandas data frame. So this is how it looks like. We have question, we have document, question, document. And so now I'll just do, I will first create a folder. I'll call it data. And then I save this to CSV data ground truth. Yes. So now if I open data, I see this question, document, question, document, question, document. Cool. So let me save that. And the next step would be to use that to evaluate our search. So as I promised, first we are going to focus on evaluating search, and we are going to evaluate our RAG and agent. As a reminder, what we are going to do is we have this, maybe I'll just draw it one more time, right? So we have this queue generated, and we have the answer for this, right? So we have 5 of them for each document. Right? And now what we can do is we can take this queue. So we will just pretend that we are user. We take this queue and we send it to our knowledge base, or we're pretending not to be the user, but it's actually like our search function, right? So we are sending this queue and we're getting back documents, right? 5 documents. And now we need to check if for this record, this answer is here. If it's here, then we were successful in retrieving this answer. If it's not there, we were not successful, right? And now we want to do it for all these documents, for all the, how many do we have? Yeah, almost 400, right? So we are going to do this for all of them. I'm going to create a new notebook, and I will call it search eval. I want to split it into multiple notebooks. So let me quickly check that this thing works. Okay, works. So right now, so what I will do is I just saved this data frame. I'm going to import, I'm going to read this. So I'll say this ground truth equals, yeah, data, well, pandas read CSV. So now, oops, if I do cut, sorry, if I do hat, I see this. So I just loaded this, the data set we created. Okay. So the next thing I want to do is I want to turn this into dictionaries. So dealing with data frame is not always convenient. So for me, I want to turn this into dictionaries that look like that. So this is essentially the same data as we ended up with at the end of the previous notebook, right? So now we have the same data in the new notebook. And now what we need to do is, so we need to define our search engine. Right? So there is some preparation that we did before, and there is some things that we haven't done. So if I go to ingest, there is this second thing, build index. So for those who have watched the previous lessons, you know what this is. We talk about this in RAG, in the RAG module. So this is the thing that you can use for search. Okay, for example, this is the search, right? And since we filter this to LLM Zoom Camp only, then we only get questions from LLM Zoom Camp, right? So this is how this works. And then we can also, what we can do here is we can say how many results we want to have. Let's say 5. And we also can say that one field is more important than the other field by boosting this field. Boost. So I can say question, for question, the boost is 3.0 because I think question, like if the question matches, question from the user matches the question from the FAQ, then it's more important. Right, so then boost dictionary. Okay, so now we see a slightly different order. So this is min search. So this is the library that is doing search. And now we have this convenience method. I call it text search. The reason I call it text search is because I want to be specific that here we focus on text search. And later, when we evaluate it with something else, we can have another function that will be vector search. And we want to make our framework evaluation, whatever we do here, like it shouldn't really care what exactly we have, what kind of function we have. And actually it matches the way RAG works, right? So in RAG, this step, right, is about search, and we don't really care what is the search function that we use here. Like as long as this function returns some results, we're fine, right? So this is how we want to do it also in evaluation. So then we can plug and play different functions, search function, I mean text search function, vector search function, different parameters maybe for the boosting arguments. Actually, we don't really need filter dictionary anymore, so I think I can remove it because this is we do this for one course. So this is our text search function, right? And now I will take the first question. So the question is it okay to join the course late if I just found it now? So this is the question that we generated. And now we want to use this function and see if we are able to. All right. So let me do it like. Yeah, maybe I will do it like that. I will pass the text. Okay, so now we get some documents, and yeah, we can see, okay, like actually what I was hoping to retrieve is what we actually retrieved, right? So this is the document I was hoping to get, and we can see that this document matches, right? So this is a good sign. So now what we can do is we can just go through the result of this text search. Let me call it result or search result, maybe. Search result. Yes, and now I can go through the search results. Let me name it results. So then it's consistent to what I have in this document. So then I can go over these results. And then actually what we also have is this document ID, right? It's Q document. So this is the document we hope to retrieve, right? So this is the document we hope to retrieve, and these things are not relevant for us, right? So now what we can do is I have this loop. I just look at the documents that we have and see, I compare, okay, is this first document the one we're looking for? Yes, it is. Is this document the one we're looking for? No, it's not, right? So then what we can do this way is we can build similar thing for all the documents, and we will get what I call a relevance matrix. I don't know if it's a proper term actually, but for the relevance matrix, what we will have is we will have where's my pen? So this is a matrix or table if you wish, if you don't like the word matrix. Right, and then we'll have it will consist of ones and zeros. So we have different positions, 1, 2, 3, 4, 5, and different documents. Document 1, document 2, or actually, like it's not D, it's these questions, right? So question 1, question 2, question 3, and so on, right? So then we know that for question 1, this document 1 is what we want to retrieve, right? So this is our ground truth, and this is what I call is relevance matrix. So here we will have 1 if we are able to retrieve it, and we will have 0 if it doesn't matches, right? So for example, for the second one, it could be something like this. And for the third one, maybe it is just all zeros. Right? So this is a relevance matrix. So I want to have this relevance matrix for all the documents that we have. And then from this relevance matrix, from this data, we can calculate different metrics to understand how good our search works. Right. So let's do that. So first I'll start with a relevance row, right? So it will be a row for the first document. So it will be like we have here. So it's going to be this first row, right? Now what we need to do is we need to do this for all the documents, right? Not just for the first one, for the rest of them too. So I want to put this inside a function that we can reuse. And yeah, so we do this for this pair. So the first thing we do is we get the document ID, then we perform the search, and then we iterate over the results, and we collect this relevance row, right? So for us will be, if I do this queue, so this is the first document. I can also do this for other documents. So for example, so yeah, this is the document number 1. Right? Is it okay to join the course late if I just found it? So this is, we are able to retrieve the proper document in position number 1. So this is the best possible outcome. Then there is another example where, let's check. So, okay, I think because here in preparation, I used a different data set. That's why now I think I'll have to adjust it. So one of them should actually be, I mean, we are very lucky. Okay, but let's say document number 11 would return something like that. And then it means that for this particular query, we were able to get, so we were able to retrieve the document we want, but I was on the second position, right? I mean, if we count from 0, 0, 1, 2, or third position if we count from 1, right? And the same thing is, again, I don't think this will work now, but at some point there will be also queries for which we cannot actually retrieve. I now wonder, because like that's too many ones. But let's see. But yeah, so here what I was expecting to get is a document like that, a relevance row like that, right? So here it would mean that we were not able to retrieve the right document. Probably when I was experimenting here, maybe the way I generated data, the instructions was not strict enough, right? So that's why. But this, like, if I, let's say, see now that all the documents actually, like for all the queries, I was able to correctly retrieve the document I wanted, it would be suspicious, right? So maybe we need to go back and reconsider, rethink how we do our synthetic data generation. So I hope I will not need to do this because we don't have a lot of time for that. So what we will do now is I will just have this function that is going through all the records we have in our ground truth data set, calculates this relevance row and puts this as in a list. And then at the end, we will have relevance matrix for ground truth. So it's pretty fast. And now if I can look at first 14 records. Oh, okay, good. So it's not hopeless. You see, we have actually things that are, things that we weren't able to retrieve at all, things on second position, things on third position. So it's okay. We can work with that. So that's it. And one last thing, as I said, I want to make it generic. I don't necessarily want to hard code this text search here. So what I want to do is I want to pass it as an argument. So let me take this function. So I'll just say it compute relevance, and then I'll have search function. And then I would just pass this search function here. And then also when I do it here, compute relevance total. I would just, let me do it in a separate row. So instead of doing it for text, I also have the search function here, and then I will replace it. Yes. So now when I do this, hey, execute. So now when I do this, I need to provide, of course, yeah, text search, something like this. See, so instead of just executing with this for text, I would just say, this is the function I want to apply. So give me the relevance. So then it should give the same results. So if I look at first 15 examples, they are, I believe, the same. Okay. So I think we are done with this one. There are some questions. Would be maybe let me check the questions before I continue to the next lesson. Will the course cover possible attacks on LLMs? No, we will not do this. How to extract text from PDFs? Well, let's discuss this at the end. How it is possible to use both of searches? Yes, it is. Okay, I have difficulty reading caps, so maybe write it better without caps, please. I don't want to read it. Okay, so let's continue with this. So now we have this relevance, right? So we have this relevance matrix. Now we want to use this relevance matrix to calculate relevance metrics. And there are multiple metrics that we can consider, right? I'm going to take this example, actually, and I'm going to illustrate this metrics with this example. So the easiest metric that we can calculate is called hit rate. I think this is what I start with. Yes, hit rate. So hit rate is we want to see in how many cases we were able to retrieve the document we wanted. So I was already showing it here. So this inclusion symbol means that the document we were hoping to retrieve is actually in the results, right? So here, if we have at least one here, it means that we count it as one, right? So for our case, so let me wait. So I want to use this. So for this case, right, we have one. For this case, we have one. For this case, we have one. For this case, we have 0. 1 again, because we have 1 here, right? Then again, 1, 1, 1, 1, 1, 1, 1, 1, 1. Okay, so we are very lucky. Again, as I said, it looks a bit suspicious to me. I would need to actually go back and reevaluate how we generate. But from what I see, so we have 15 examples, and 14 of them actually we were able to retrieve. So our hit rate is very good. So maybe we got lucky. I think, yeah, I would actually go back and try to make our examples more realistic, because this is, I don't think it's possible in reality to have such a good hit rate, right? So this is a problem we have with generated data sets. Sometimes they're too synthetic. They don't really represent how people query, right? So this is something we need to keep in mind. Like I think in this particular case, it's too good. Well, at least we have one missing thing. This is good. So it's not 100%. But in our case, so as I said, we had hit rate of this 93%. Yeah. So I think what I will do now, not right now, I mean, after I finish recording, what I will do is I'll try to generate a more realistic data set. And this is what I'll use to actually put in the lesson materials, right? So right now, we're going to use this one. And probably I'll just use the one I prepared before, because I don't think this is really interesting for us to see, like, this is just too good, right? And what I will do now, therefore, is I will go back and I will download the data set that I prepared in advance. So I think I need to go one more. Yeah. So ground truth data. I'll call this one new. I will still commit it, so then you can still see it and experiment, like, just for the sake of reproducibility. But yeah, right now what I want to do is I want to use ground truth data. So I want results that aren't that good. So then here we have course, it's okay. So this is something I didn't want to include. So then I will basically redo this whole thing. I just had a notification from Zoom, and it was so loud. I jumped. Okay. So now compute relevance. And so yeah, now the picture is, it's not that different, to be honest. Okay, maybe it's just the first 15 examples. Anyways, let's continue. So I'll see which one I use. So I'll compare different metrics, because right now I also see that for this one that I took, it's also quite good. Anyways, so let's see. Virtualization. So we computed hit, right? And with hit, what we do is we just check if one is in the row or not. So this is very simple to implement. And where do I have this? Yeah, this is really, really simple to implement. So we just go through each line. So in this example, we just check, okay, this is the line, is one here or not? If one here is here or not? And then at the end, if we see that one is here many times, or we just count how many times we see this one here. Let me take this sample. Okay, it's 14. And then at the end, what we do is we just divide it by the total number of examples we have, and this is how we calculate it. So I want to put this inside a function, and we'll call this function hit rate, right? So we go through each line in this example. If we see if one is there, we increase the counter, and that at the end we just divide it. So it's 88. And I want to quickly check, maybe I was too, too quick to judge. So I called it ground truth new. So maybe I was too quick to judge. So I want to quickly check these two to see if actually, I think it's the same. Okay, and then let's continue using this one. So let's continue using the new one. So again, it's kind of pretty large, I would say. But yeah, I would need to go back here in data generation and really think, like, is this representative? Are these questions representative of how users interact with my system? Because for this particular example, the answer is no, it's not really representative. So I would need to tweak it. Okay, so we calculated our hit rate, right? So this is our hit rate. The problem with hit rate is because we don't really look at the position. So here, this is a good result, right? So here, 1 is at the position where we want. But here, it's not ideal, right? It's or here, it's not ideal. So here the position is first. Here the position is second. Here again first. Here we don't have anything. And it's second position, first position. I'll just do it for all of these things here. First, right? So we want to take this into account. So for things that we have where the element is on the position, the element we want to retrieve is on the position where we want, we give top score. So for this one, oops, sorry. So for this one, I give 100%. Yeah, so this is good. So for all the ones that we have here, so the score is 100%. So this is good. Right? For this one, when it's second, I want to give it less. So I want to give, instead of giving 100%, I want to give it, let's say, 50%. It's okay, but like second, like it better be first, right? Then for this one, I want to give it 33%. Right? And then if something is on the fourth position, it would be 25%. And if something on the fifth position, or 5, right? So if something is on position on rank 1, then it's 100%. So what we do is we just divide. Wait, what is the formula? So we take 1 and divide by rank. Yes. So if rank is 1, so 1 is 100% or 1, right? Clean this. So this called when we actually look at the position, it's called MRR. So the previous one was hit rate, whether we hit the right document or not. And MRR stands for mean reciprocal rank, right? Reciprocal, I think, it just means that we divide this, and mean means that we take an average, right? So when we calculate, so it's 100% here, 50% here, and so on. And then we then take the average, and we get, I don't know, 60%. And this is our MRR. And if you notice that hit rate and MRR, they are very similar. And MRR is always smaller than hit rate, because for hit rate, it's basically MRR where everything is always on the position number 1, right? So MRR is always, it's the upper bound. Hit rate is the upper bound for MRR. So then let's calculate this MRR. It's also pretty straightforward, right? So we already did this. So maybe just to do this out, this thing, right? So this is our hit rate, right? So here we do, if 1 is in line, then we increase the counter. So what I will do now is I will iterate for, okay, I think it was actually listening to us, or maybe it saw this. Let me just take it slower, right? For rank in range, then line. So this is a loop, right? Now we check if, okay, I'll just go with this. So if we check if we see one, so here, if we see one at this position, we stop. If we see one at this position, we stop. If we see one at this position, we stop, or we stop where do we have whole zeros? Anyways, like eventually we stop, right? And whatever we see would be our let me actually do score. And then instead of counting, I'll call it total score. I'll start with 0.0. So then I will do total score equals total score plus score. I notice this rank plus 1. Right? So instead of just rank, I do rank plus 1 because in Python we start with 0. Right? That's why I want to start with 1. Because if we start with 0, it's 1 divided by 0, which is which doesn't it's what, infinity. Anyways, yeah, we cannot divide by 0. That's why we add 1. So this is our proper rank. This part I remove. And then we just, in order to calculate MRR, we divide by total score, right? So, and then you see it's smaller than hit rate. So MRR is always smaller than mean rate. And for many practical cases, I mean, for LLMs, they are usually smart enough to figure out of 5 small documents, they're smart enough to figure out what is relevant. But usually, the higher the relevant document is in our list, the better. Right? So then the LLM will not need to scan too many things. Okay, so we can put this inside this function. So I just took this code and put it inside the function. I think I actually like this implementation more, the one I just came up with. So I'll keep this one, but instead of sample, I'll use relevance. So the reason I like it more is because I have the score separately from counting. I think it's more readable. So now I can do MRR for our entire relevance. What is it? How do we call it? Yeah, for sample. Ah, right. Return. Okay. So now I want to do it for this entire thing. Ah, yeah. I just need to be more patient. I think it's some connection stuff. Can you actually? I'm still audible. Yeah, I think so. I have some problems with Okay, I am back. I'm sorry about that. So I had to switch to my mobile hotspot. And yeah, I was just thinking, okay, why this MRR doesn't work? But yeah, the problem was that I didn't have yeah. So let me know where did I stop? So let me check live chat. So my computer is still loading. Yes, I am back already. Says the host will be back. Okay. Can you hear me now? Can you hear me well? Let me just check. Yeah, I can hear myself on my phone. Okay, so I was talking about this relevance, right? So I don't know where we lost it. So we compute relevance. I quickly noticed that there is an error, so I fixed it. And then for the sample, this is the MRR, and for relevance, for the entire thing, this is the MRR. Okay, sorry about the connection. Now I should be back. Now I'm on mobile hotspot, so whatever they are doing in the building, maybe they're fixing some things. I shouldn't be affected. Okay, so now we have this hit rate and MRR, and I see that there are some questions about hit rate. Now let me take a moment to answer that. High hit rate doesn't guarantee the best answer on top. How can I filter or re-rank the top 3 results to ensure the most accurate context is used? So I think I partly answered that. So yes, indeed, a hit rate does not guarantee the best answer on top, right? And MRR is a better metric to reflect how close your answer is on top or not. And to answer your second question, like how can you guarantee or re-rank that the top results are relevant? So there are things called re-rankers. You can, first of all, you can use an LLM. You can say, okay, this is my query. This is my results. Can you please rank them? I wouldn't do this necessarily because for our case, like when we just send these 5 documents, it's fine, right? So it doesn't change much whether the result is in the first row or in the second row or in the third row. In some cases, you might want to work on your search function. So we will see how we can tune our search function today, right? We already have this ground truth data set, so we can see how we can tune our function. That's one thing. Another thing is we can also create some sort of machine learning model for re-ranking, right? So this is outside of the scope for this course, but like typically you don't really want to delegate this to an LLM because it adds more latency. It's also not cheap. So if you really see that you're hitting the wall with your search and the LLM, like you really see that in some cases where the results are at the top, in these cases, the LLM performs better than in cases where the results are at the bottom. So then you can improve your search function by maybe using vector search, maybe using some sort of machine learning models. But yeah, there is always a way to improve. What are the threshold rates of hit rate and MRR in reality? What are good thresholds to aspire for? I mean, it really depends on your use case. Sometimes if you retrieve like in 50% of cases, you retrieve the right result, it's good, but it doesn't mean that the rest of the results are necessarily bad, right? Maybe they're also okay. Okay, the reason I'm saying that is because of the way how we generated our data. We assume the assumption is that there is only one relevant result. So if you look at this thing, we have only one per row, right? Only single one per row. We don't have two ones. But in reality is maybe this second document is also relevant. Maybe the third document is also relevant. Only if we, instead of using generated data, if we actually look at the results and do some sort of manual evaluation or ask an LLM to evaluate this, then we will know that, okay, this one is also relevant, this one is also relevant. So sometimes if we use this approach and our hit rate is 50%, who knows, maybe these ones are good too, right? So that's one thing. Another thing, it depends on your product and business. So in some cases, maybe like if the LLM can still do something from these answers, even though they are not necessarily super relevant, maybe it's good. Like so, you also need to evaluate this entire system, holistically. Yeah, that's the right word. So I don't know what is the right threshold, right? It really depends on your application. Okay, so I'll continue. So where did we stop? Yeah. So we talked about MRR, we talked about hit rate. So now I want to put everything together and have a function that I can use. Let me see this search function that I can use to actually compute relevance for everything at once. So I just say, okay, this is my search function. This could be text search, this could be vector search, this could be, I don't know, hybrid search, this could be some machine learning approach that that is doing everything, right? So there is a function. And this function gives me the relevance matrix, and I can compute this matrix from this relevance matrix, and this is all I care. And at the end, I can use this approach to actually compare different methods, right? So let's say we know that in our case, search is really important. Right now, our search is 60% MRR, right? And we want to improve it to 80%. Then we, let's say, swap text search with vector search, and we see an improvement, then it's already quite good, right? So then we say, okay, we go with vector search. So yeah, so I want to make it agnostic, and then calling this function is really simple. So this is what we've already used. Here we just compute hit rate, and so I'll do it like that. So we run our blade on ground truth and text search, and this is what we get. So it should be the same, right? Yes. So now let's say we want to improve MRR, and we know what to do, right? We just try a different function here, we put it here, and we see if MRR is getting better or not. And it still looks suspicious, but okay. Like I would expect in reality, when documents are, with real questions from users, probably the hit rate would be lower, right? So in our case, I think it's just too close to answers. So again, we need to treat these numbers with care. I can treat them as just an overview of how not an overview of what I want to say is just it gives us some idea how our system is performing. But in order to really know how it's performing, we need real user data and we need real evaluation, right? This is expensive to get, or not? It could be expensive to get, more difficult to get, but this would be the next step, right? So the first step, you do it with synthetic data. You also try to tune your synthetic data generation in such a way that it resembles user data. Then you evaluate it on this. You see, okay, like now I have a good search function. Now I can actually roll it to production. And then you start collecting real user data. Then you start evaluating this real user data to get this ground truth data set. And then you can actually do like a more realistic, you will get more realistic numbers, let's say like that. Okay. As I said, now we have this framework for evaluating our search. So how about we use it? And the way we can use it is we can put different search functions and see how they perform. And what I want to change, what I want to try differently is, let me find our search function. So I think it's somewhere at the beginning, right? So this is our search function. So I'll put this at the end. And what I want to experiment, I will not do vector search right now. So this is something you can do later to see how much boost you will get with vector search. But what I want to do now is, so right now I think this is just my gut feeling that if I set the boosting for question to 3, and I set the boosting to section to 0.5, I get the best performance, right? So, and the logic here is that the user is asking a question, and if the question is matching the question from the FAQ data set, then it's better than if the question is matching some random words in the answer, right? And the section is like, we probably don't think it's really important, so maybe these matches from there aren't really useful for us, right? So this is the premise, this is the idea, and now I want to check if my idea, my gut feeling I relied on so far, is actually correct. And now we can do, we have the, what we can do this, we have the framework of actually doing that, right? So now we can just try different, we can try 2, we can try 1, we can try 5, and then we can run this. So maybe let me do this. Text search, I'll call it V2, and I change it to 2, and then I put it here, and then I see what I get. And what I get is actually, if I put question to 2, if I boost the question to 2 instead of 3, it's actually better. We can see that MRR is improving 3%, right? So it means that maybe in my initial suspicion that I need to boost question is not right. So what we can do now is we can just iterate over all boosting parameters. We can try different ones, and we see where hit rate and MRR are the best ones. So that's this parameter to different arguments. So I'll call this function search boost. Right? So now we have different parameters. So we will start with question. I don't need this filter. So we'll start with question, right? And then we'll try different values for this question. Then we'll try different values for answer. So right now for the answer, the boosting is 1, right? So we don't do any boosting. So then perhaps we can also try different boosting for answers. And then we can see where we land, right? So let's start with, so what I'm doing is called grid search optimization, right? So we're just trying different parameters and we see what is the best one. So now let us try to do this for different boosting parameters. I'll also add this one. Like, what if the question is, it's really better not to boost it at all? Okay, so we're getting some results. And from what I see, my initial idea of that I need to boost question is actually not correct. So I see the best MRR I can obtain when my boost is 1, and actually boosting 0.5 is even better than boosting 3. So it means that actually data says that boosting question compared to boosting answer is like we should actually give more importance to answer rather than to question, right? So this is what the data is showing. So say, hey, like how about, because right now when I boost it to 0.5, it means the answer is 2 times more important because boost for other answer is 1, right? So it means that, yeah, so it's actually better. And then I see the boost of 1 is the best MRR. So let's see now, let's try to check. Oh yeah, we can actually check them all, right? So we have question boost, answer boost, section boost. So how about we just, so this is called grid search. So because this is really fast, like really, we just take 1 second to evaluate this thing. So it means that we can actually go ahead and try different combinations and see which one is the best one for us. I'm going to remove this thing. And then, yeah, you see, we go over all possible question boost, answer boost, and section boost. So of course, like maybe I should add. So yeah, right now, because I did this, we are going to wait a bit longer. But yeah, let's see that. So let me. I think I need to also add a print statement here that we know that something is happening, right? But then we will collect the results here, and then we will put these results in a data frame, and then we will present this. Okay. So let's wait. I think there are questions, right? So let me take a look at the questions. So question from Tarun, top K basically governs whether we can get correct answer, right? So there are jargon heavy pages which get ranked higher, but actual values we might want to appear later in the relevance results. Okay, so I guess the question is about top K, right? So top K controls how many documents we have. So right now our top K is 5. We return only 5 results. And of course, if you increase top K to 10, you will hit 1 more often, right? So maybe for this one, where do we have it? So we should have one, yeah, for this one. So maybe the one here is on the 6th position, right? So if we now get top K 10, then we will hit once more often. But then we will overwhelm the LLM with data that is not relevant, right? So if now we send 10 results instead of 5, not only we pay more, right, but also for the LLM, is more difficult now to select what is important, what is not. Did it finish? Okay, so now let me check. No, that's a lot. So in reality, for this data set, yes, we can do this. We can do grid search because this is very fast. In reality, you will probably want to do something like Bayesian optimization, right? So you will use a library, hyper opt or something like that, that will let you select the best parameters. Right? So instead of doing grid search and spending a lot of time and resources, let's say if evaluating a search takes 5 minutes instead of 1 second, right? So you cannot just afford doing this grid search, right? So you need something smarter. And then in these cases, you would use something like HyperOpt or some other optimizers. Okay, now I want to turn this into a data frame. So call it, what do I actually call it here? Is it here? Yeah, we'll call it results. So now we can turn this into a data frame and then sort by MRR. And then we see that the best MRR is achieved when answer is 2 times more important than question, and we give very little boost to section. So the smaller the boost to section, the better. And now I see that these ones, so we have this kind of cluster, right? So they are the same. They have the same hit rate, the same MRR. And the reason is they're just, how to say, linear combination. Anyways, so 1, 2, and 0.5 in boosting is the same as 2, 4, and 0.2. So because this is just a multiple of 2, right? And the same here. So we just take this one, multiply by 5. The ranking is still the same. That's why nothing is really changing here. But from what we see, this is the best combination, right? So because now we have this framework, we have this ground truth data, we not only can evaluate our existing function and see where we stand, we can also tune it. We can also compare it with other functions, right? With search, like let's say we want to compare it with vector search. In vector search, there are different embeddings. We can have small embeddings, we can have big embeddings. So like, does it matter if we have a small embedding model versus a bigger embedding model? So these questions we now can answer. And I see that I'm already taking 2 hours. And I only covered text search evaluation. So this is taking more time than I anticipated. So what I will do, I will still continue. I will still continue, and because I need to record these materials for the actual course. So that's what I will do right now. So what we did is so far is we turned our, let me open this model. So what we did so far is we covered this search evaluation part. Now I'm going to cover RAG and agent evaluation part, right? It's going to take maybe, who knows, like maybe 1 more hour. I don't know. I feel tired, to be honest, but yeah. Let's start. So I already gave you the idea of what we want to do. We have this, I'm going too far. So we have this data, right? So we have this fake data that we generated, right? So what we can do now is we use the entire RAG, like the entire RAG. So we go to assistant, we question the knowledge base, we create a knowledge base, we get the prompt, we send it to an LLM, and then at the end, there is an answer that we get, right? So we compare it with the, how to say, with the answer we expect to see. So we see, okay, is this A, how similar it is to the A we expect? Preference answer. So that was the word I was looking for. So if the answer we get is very close to the reference answer, then we're good. So now what we want to do in order to evaluate RAG is we want to go through this entire data set we have, the ground truth data set. For each of the records we have, we want to get this RAG, right? And we want to compare that what we get from RAG, and we want to compare it to our A, right? So I think it's very similar to what we were doing here, where, yeah, well, basically, yeah. So we compare, right? And we see, okay, is it similar or not? And what we are going to do to compare is we'll just show an LLM. We say, okay, hey, LLM, this is the answer. This is the question the user had. This is the reference answer. And this is the answer that LLM has generated. Do you think the answer that LLM has generated actually similar to what we expect to get or not? Right? And the reason we use LLM here is because the answers will be different, right? So it will not be the same answer because LLMs are generative models. So they will generate something and all the words could be different, but the meaning is still the same, right? So this is why we want to rely on an LLM to tell us if this A here, if these two answers they match, right? So that's why we will relate on an LLM. And I want to start by loading this ground truth data. So I'll have 803 RAG evals, a Python notebook. So I call it, I think, ground truth new. Okay, I can close this one. Yeah, so I'm going to now generate this data. Sorry, load this data. So this is the same ground truth data we had so far, right? And again, because I created a new notebook, I want to get the data, I want to build the index, and the reason I want to build the index now is because I don't evaluate search function directly, but search is still a part of RAG, right? So that's why I still need search, right? Because it's a part of RAG. And then another thing is we need to be able to retrieve, so here we have only document, right? So we don't have the reference question. So now from this document, we want to be able to, we want to know what is the actual question, what is the original question, what is the original answer. Or original question is not maybe important, but what is the original answer? So for this one, if let's say I call this RQ, so then what I want to do is I also want to show document what is the document that was used to generate this one. So then now we can combine it, we can send it to an LLM, and then LLM will decide is it good or not. And by the way, I don't think I mentioned that the approach of using LLM to evaluate the results of an LLM is called LLM as a judge. So we ask an LLM to evaluate the LLM, and these LLMs that evaluate other LLMs are called judges. So this is just terminology, but let me set this thing up. So what I'm setting up is the OpenAI thing. So we have done this multiple times already. And now there is another thing I added before this class, right? So we already talked about this utility class. And here I have this RAG with usage. But before I explain what this RAG usage is, I am going to explain what this RAG helper is. So RAG helper is the utility class we created in lesson number 1, and it just puts everything together for RAG, everything we need for RAG. So RAG is, if I scroll down, so RAG is first step is search, then we're building prompt, then we are doing the LLM. So this is RAG. So this is the first step, this is the second step, and this is the first step. So now we encode everything in this RAG function, right? And then we separately implement search. We already have the search function, right, from the past. Then build prompt. This is how we inject the results from the search results to the prompt. And this is actually how we send it to an LLM, right? So what I want to do now is I want to take this class and I want to extend it. So I want to add a bit more functionality for this class. And what I want to do is I want to track usage. So I want to track how much money I spent on making this evaluation, right? So for me, it's important because I don't want to pay too much for these things. So I want to know how much I pay, right? So then I created a class that is called RAG with usage. And we have already seen this today, right? So we use, we just track the response usage, right? And what I do is inside I have a field called usages. It's right here. It's empty when we start, right? And then every time we make a call to this LLM, we track this, right? And at the end, I can just say total cost, ask for total cost. It would iterate over all the usages and it would give me the total cost, right? So this is for us just to know what is the price, how much we pay. Otherwise, it is the same RAG as before. And by the way, so here we also, I also updated the search function to include the optimized parameters, right? So this we found in the previous lesson, we found that actually this is better than what we had before. So my assumption about question being 3 times more important, we couldn't prove this with data. The data showed otherwise, right? So what we also can do here is we can put the new data, right? So now when we actually run our RAG evaluation, we use the new search, right? So then we are the results that we'll get will be better. So then we can see what these results are, right? Okay, so that's what I'm going to import right now. And for RAG, yeah, it's the same. We need to say what is the index and we need to say what is the client. I think this is just these 2 things we need to set for this particular one. I think we already set the course here. No, yeah, we set the course, which is in our case, it doesn't really matter, right? Because it's only one course. So it would be none, I think, right? Maybe I should just to be on the safe side, set it to LLMs on cap. And then we perform search. And here we collect usage. Okay. So that's our assistant. And we can quickly check it. So when I do RAG, we get our first Q, right? Q question. So now it's actually performing RAG. So it's doing the retrieval. It's sending this to the LLM. And then this is the answer we get. You can join office hours or live workshops without Zoom link by watching. Okay, what was the actual question? How do I join office hours? Okay, so this will be answer. Right? And now we want to understand how similar this answer to what we expect, because this is what we expect, right? So this is, let me print it. So this is the answer, and this is the canonical answer, the reference answer. So now we need to compare these two. And for that, we use another LLM as a judge. But we will do this later in the next lesson. Right now, what I want to do is I want to just collect all these things together. So then we can actually run LLM as a judge on all the questions, right? So let's do that. So for that, I need a way to put everything together, right? So I need to put a way to, I think I skipped a few parts, so. Yeah, the cost, well, let's check what the cost was. So this was the, I think I already made a few calls to Assistant, so it will show me the cost so far, right? So for all the queries I did so far. And if I made only one query, I think I did two, right? It would show me the cost for one query. So this is how much I spent so far. And then I want to put it in such a way that for me, it's easy to feed to the LLM. So we need to put everything together. So right now we have this answer, we have this document, we have the original ground truth record. We need to put everything together. So we will start with document ID. Okay, I have record. I think I used Q, right? So then we use the, we do this extraction, we get another extraction lookup. We look up, then we see what is the original answer. So this is the original answer. Yeah, so I don't actually need this. So this is the original answer. So this answer we generated. This is the original answer. Now we need to put this together. And I think here I call it answer. Yes. So now let's see. So this is the record for us. Question, how do I join office hours? Answer from LLM, you don't need the Zoom link, and answer original, our reference answer, the Zoom link is only published to section. So basically, yeah, you are not getting the Zoom link like on this call right now. You're watching it through YouTube. You're not getting the Zoom link. Okay, so now I want to process that all. So I have a helper function that puts everything together. So this is what we did so far. Okay, I had to adjust the code a little bit, but here we do it for record, right? So we get question, we get doc ID, we look it up, we send it through RAG, then we get the original one, then we put this together and we return it, right? So this is the entire evaluation. Now, if I do generate a RAG answer, record. So I will actually see, like it will do this one more time. Yeah, so students don't use the Zoom link directly. So I did that. And now I want to, like, if I do assistant total cost, like it keeps increasing, right? So I need to reset it. What is reset usage? So now total cost will be 0. And now I will apply it to all the data we have. So I'm going to use the same approach as we used before, right? So I'm going to use this thread pool executor, and let me check. So actually, like in our RAG, ideally, we should have used our retry mechanism. So I don't know. Now maybe we'll later. I think I'll update it to use the retrial. But now let's just hope for the best that we will not need to deal with this kind of stuff. So right now I'm generating it for all the data. It's going to take some time. And let me check the questions. Why lessons online now? If bootcamp starts in June. So right now I'm just re-recording everything for the bootcamp. So it's a way to promote the course. So now you're joining, you're finding out about the course, and then you're registering for the course. So then YouTube will recommend this video to people, so they will find out about the course. And it's for me to pre-record it. So later I will edit these things and I will put this in the course lessons. And then you can watch this later in recording too. So yeah, maybe you can ask more questions because now we have to wait for this. Yeah. So when I was recording this without doing it online, I would just put recording on hold and then wait. And then when it finishes, I'll just resume it. Right now, we cannot do this. Yeah, so if you're watching this right now, you can just, fast forward it. Okay. because I don't think when I will edit this later for the actual Zoom camp, I'm going to really cut this part. I'll probably do like simple edits, like splitting it into proper chapters, or not proper chapters, like proper standalone videos. But then that would be it. So I don't think I'll do more than that. Okay, maybe I shouldn't have shown this entire thing. 10. Okay. So now we did this for all the questions. I was really lucky because it just worked. So we didn't hit any usage limits. We didn't need to run the retry thing. But in the future, I need to take a note that the trial is important. Right. So here the request direct retry. Okay. These are the results. Now I want to how do we call it? The results. So I want to turn this into a data frame. Okay. Pilot. Yeah. And now I want to save it to what? Yeah, we want to check total cost, of course. And after that, 33 cents. And after that, so I spent 32 cents. Now it's 33. After that, I want to save it. So I'll call it track answers new. And it's DF results. Yeah. Okay. So now this is done. We have the answers from RAG that we generated from ground truth, right? And so this is not the evaluation yet. We want to evaluate it. And this is what we will do next. So now we will use this approach that I described as LLM as a judge. We will look at this query. Oh, sorry. We'll look at the answer from the LLM. We'll look at the original answer, and we will see how similar they are. And based on that, we will compare all the questions, all the answers across all the entire document. And then we will see, okay, this is how good your RAG is. And so that's the plan. So now, yeah, here the plan for me was to start a new notebook. Maybe I'll just continue here with this one. So yeah, let me skip that part. Yes, we again are going to use structured output. And for this output, we will have two things. We will have the score or verdict, whether it's good or bad. Good means that the answer is correct and complete, bad if it's not, right? And what we also include is reasoning. We force the LLM to describe why the answer is good or why the answer is bad. We don't necessarily want to read this then, maybe for debugging, but for us, we just want to LLM force to think, kind of, not to think, but like when it also needs to explain why something is good or bad, generally we get better quality of these predictions, or not predictions, but like classification. Yeah. So then we have these instructions. So it's kind of similar to this part when we were generating ground truth, right? So we have the structured output, we have the instructions. So the instructions are, you're an expert evaluator, you will be given a question from the student, original answer, an answer generated by an AI assistant. And your task is to decide if the AI answer is semantically equivalent to the original answer, right? So rules, the AI answer does not need to be word-to-word identical. It should convey the same key information. Extra details are fine. Mark bad only if the AI answer is wrong or misses the key point. Okay, so that's what we want to use for evaluation. And right now, instead of just sending this in JSON like we were doing before, we actually want to have some sort of template, right? So we want to put the question. This is the question from the student, the one we generated. This is the original answer, right? The reference answer, and this is the answer that a LLM has generated, right? And then we will ask the LLM to compare these two. Right? And I think I will skip these things. And I think I call it results, right, not answers. So we'll start. Okay. So why did it reset the whole thing? Well, since actually it turns out that my kernel died, so I might as well just do into 04 LM judge Python. So I might as well just copy all these things. So I'll remove these things. So I wanted to save some time, but Codespaces decided that I don't need and just randomly restarted my kernel, which, yeah, not great. Okay, so I'm copying this thing again. Now the instructions, the template, we do some imports. So all the imports we will need to calculate price and things like that. So we have seen this multiple times already, and then let's start the first record. And by the way, I think what I wanted to, did we already load it? I think I skipped that part here. Yeah. So I'll do this now. And it's RAG answers new. And what is wrong? Why did I call it news? New, yeah. So I'll have to change it here too. Okay, so answers are there, and then we can get the first record from there just for us to see what we have. So this is something we are going to experiment with. We have the answer, the original answer. We have the answer from the LLM. Now we need to compare. So let's do that. We use this LLM structured retry. We also need a prompt, right? So prompt is here. So what we do is we just format. So this thing here, we can replace question by and answer original and answer LLM by formatting. So this is how our prompt, what we send to the LLM prompt, this is how it will look like, right? So we have question, we have original answer, we have AI answer. And now we send the instructions, the prompt, and the output type to the LLM. And then we will see if it's good. So I think this should be good. Says the AI answer preserves the key meaning of the ground truth. The joining is allowed, and so on. Score good. Okay. We can also make it a little less verbose. I think it's fine. Right? So usually when it goes into detail, explaining things, then the quality of the classification of the decision is better. So the price, let's see what the price is. So yeah, again, quite little. So what we will do now is we will just run everything for all the records, right? So then of course we need for that to put it in one function. So everything we did so far, building the prompt, then sending this to the LM, and then returning the result, the classification result and usage. So now we have everything in one prompt. The only thing we need to do now is to run it for all the records. I'll quickly test that things work with this new function. So this is the same thing as before, right? So now I'm just going to run it for everything. So I'm speeding up right now. Maybe you noticed that because I want to finish it quickly. It's been some time, so kind of speeding things up and copy pasting quickly. But yeah, later when you're watching this in a course, you can take your time and try to figure out what's happening. But so far, we're not doing much here. So we're just taking this thing and putting it here, right? And then we, right now it's in this format, right? But we want to turn this into a dictionary, something we can save later, right? So we take the question, we take the document we need, we score, right? So then we will know that, okay, for this question, this was the score, like this was the verdict, the prediction, and we also keep the reasoning just in case, right? If we want to debug it. So this is the function. Perhaps maybe we want to save more information, perhaps also maybe for each ground truth element, we want to have some sort of ID. We would add it here. And now we run this in parallel. So we do this for all the things. And yeah, should be pretty fast. So I'll just take a small break while it's doing this, and I'll be right back in 1 minute. It's still computing. I think we're almost there. So just a couple of seconds left. Cool. So it's done. So we have the results. And the results look like that. Again, we have usage. We have these things, reasoning. Okay. So now let's put everything. So in the same way. So I want to split them, right? So one thing will go to one list, another thing will go to another list. So then we'll calculate the price and we'll get all the evaluation results. So we will have our data frame, and I want to calculate actually first, I want to calculate the usage, and then we will see what we have inside our data frame, 25 cents. So I think today in total we spent like 75 cents or something like this, still less than $1, but I think this is going to be the most expensive lesson or the most expensive model. And of course, what you can do is you can just get the data that I generated here, and then you will not need to spend much. Maybe you can just run it for, I don't know, 10 examples just to understand the concept. So now let's take a look at this data frame a while. So what do we have here? So I'll just look at head. So what we have here is we have question and we have score, right? So what we can do now is we can do score value counts to see this is how many good and bad ones we have. What we can also do is I can do more lives true, and we will see the same in percent. So it means that for this particular data set, our RAG gives good answers in 95% of cases. So I think this one's is when it was not able to retrieve the right data. But according to the LLM, even in cases, I think our hit rate, what was it? So let me quickly check what our hit rate was. think it's a bit higher, right? So even in cases where there was no result, according to the LLM, according to this judge, the result was still good, right? So maybe our judge is actually too, how to say, not strict at all. Maybe we need to make our judge stricter, but this is the first result, right? So this is something we can now use to try to debug, to understand, okay, what are the cases where it's good, what are the cases where it's bad. I would sample some data and I would try to look at this data and understand, like, is my judge good? Or I need to actually go back and update the prompt and make the judge more strict, right? Because otherwise it says good about something that is not good, right? So this is a lot of trial and error, and this is a lot of work. I'm skipping this part here for the course, but like when you do this for your project, you will definitely have to go through these things. And yeah, at the end you can also see what are the actual bad things, right? So this is how you inspect it. Now, what I also like doing is you can use an AI assistant to actually generate, like, let's say you can use Streamlit, or you can create a web application, I don't know, in React or whatever. You can ask your AI assistant, hey, can you please make me an application where I can explore this data set and I can actually say, is this evaluation correct or this evaluation is not correct? Because what you will also need to do is you will need to evaluate the judge. And usually for that, you cannot use another judge to evaluate the judge. You need to do it yourself. And then you will collect some feedback. You will see in how many cases the judge is correct or not correct. And then you will use this information to actually adjust the behavior of your judge. And then I will save these results again as new. I will make these results available for you. So I think, let me check if this matches what I had. So I think in my initial evaluation, the data was a little bit, yeah. So here we did it a bit better. And this is how we evaluate RAG. So we use this LLM as a judge. But we can also use the same approach for evaluating agents. And this is the next lesson. In addition to, I'm not going to go into details, and I'll leave this for you for reading. So you can just go through this lesson and read and try things, because we have spent so much time already on this video. The idea here is very similar, right? So we can use an agent instead of RAG to generate the final answer, right? Because if we talk about agents here, right? So when we talk to an agent, we still talk to an assistant, but then the assistant will decide, assistant as an agent will decide to invoke the search function one or multiple times. And at the end, we still get the answer, right? And then we can still use the same approach for evaluating whether this answer is good or not. In addition to that, we can collect, we call these trajectories, all the tool calls that the agent is making, right? And then we can put this somewhere in our data frame. And then in addition to just asking the final answer, whether the final answer is good enough or not, we can also ask the judge to evaluate these trajectories, right? And then you can see the code here. So here we extract tool calls, right? And then we can save these tool calls, and then we can add this to our prompt. So if here the prompt we have don't contain tool calls, where is it? Somewhere, right? We would add the tool calls in the prompt, and then we would ask the judge to check this too, right? So that's the main thing. You see, like, in addition to checking whether the answer is good or not, we also check if the trajectory is good or not, right? And then we'll have two scores, right? And we also describe, we already described, but then in addition to that, we also describe what is a good trajectory and what is a bad trajectory. Like, let's say if our agent is starting to use the search tool and it goes crazy with using this search tool, and then it uses it 10 times, then it's definitely a bad use of the tool. Right, and then you do this, and then at the end you'll have something very similar, right? So actually that's it. I will stop right now. I'm just thinking if there is anything I want to say. Yeah. So maybe last things. I think I mentioned a few important things already, right? So generated data is good when you don't have any data, but this is not necessarily always a good proxy for real data. So it's just to get you started. The earlier you start getting real data, the better. Then once you get real data, you can try to adjust your data generator process in order to mimic what the real data looks like. And then you can generate more representative examples. And then the evaluation metrics you are going to get out of this framework that we described here is going to be more, is going to be better, right? Even if you just start collecting the questions from the users and then you point it to, I don't know, an AI system, and you say, okay, these are the questions I get. I want to generate something similar. Can you extract a pattern? Can you create a prompt from that? It will already be a good step. And then the next step you can do is you will generate this data and follow exactly the same procedure as we did today, right? The second thing you can do is you can start labeling the data that is coming from your production, right? So this is really also really important. And the earlier you can start doing this, the better. So this synthetic data that we generated today will highlight some problems you have, but not all of them. But it will certainly bring some things up that maybe you weren't expecting to see. Also, nothing beats manual evaluation and thinking about things in advance. Like, you know your application and you can think about, okay, these are the things I want to try. So then you try it yourself manually and you collect the data and you evaluate this data manually. I think this would be a really, really good step in addition to the synthetic generating data. So what I wanted to cover mostly in this lesson is evaluating search. I think search is really important, and most of the time we spend evaluating search, which is good. I thought I would take less time on that, but this is what it is. And using judges is also important. I also want you to check the old content. Here, I think this one, or maybe, yeah, because also in the last year, in last years, I used other approaches, also like cosine similarity, which I decided to drop this year because it was already quite a lot of content. But like if you want to see other ways of evaluating, you can check old content, and maybe you will like my explanation from the old videos better, like depending how much time you have. And yeah, if you're really interested in this topic, you can check out the older content too. But I also want to finish it with saying that evaluation is the most important part of creating AI systems, right? So this is the most important one. It's the most time-consuming one, but only after doing evaluation, you can be more certain that your system actually works, right? So you need to do this. And every time you make changes, you make a prompt in your agent, you make a prompt, you make a prompt change in your agent, you make a prompt change in your RAG, you change the model, you do any change, you want to make sure that your numbers, your evaluation numbers don't go down. And the evaluation framework gives you structure to actually do that. So evaluation is the most important thing when it comes to creating practical systems for practical AI systems. So that's all. Thanks for sticking around for so long. It was a long session. I am tired, so I'll go rest. I'll go have lunch. So yeah, it was nice being here, and see you soon. Bye.